multi-cloud, and so on. So we will also look into different types of implementations of cloud, right? So different types of implementations of cloud. And before that, let us go through some of the different advantages from a business point of view. So if you remember in one of the initial classes, this is what I emphasized. So to me, cloud is more innovative from a business point of view. The business innovation is more compared to the technological innovation. Of course, there is technological innovation and there is so much of continuity in innovation in terms of the technology. But to me, from the business point of view, the type of service offering that cloud gives, that is more advantageous. So let us look at point wise some of the different business advantages of cloud computing. The first one, in a different way, we had already discussed. There is almost negligible cost for upfront infrastructure investment, right? So what it means is that so almost there is no investment, because if you really need any computing infrastructure, all you need to do is to register yourself with a cloud service, right? And typically we are talking about a public cloud service. Even this is true for other different types of cloud deployment models as well. So what you need is basically simply to pay for the units of computing resources that you need. Okay, so you do not need to go and purchase a server. You do not really need to build a data center or anything of that sort, right? So all you need is simply to subscribe to the cloud computing services typically through some portal, right? Typically, why I say typically is most of the the public cloud based ones are typically through some portal. But sometimes for private cloud or other different types of non-public cloud, you do not really have any kind of portal, but you have to go through an offline kind of registration process, right? So this is the first one. And the next one is the availability of infrastructure real time. Not only real time means at any time whatever you need, you can scale up, down. It's completely elastic, as I spoke in a previous class. Real time, elastic, on demand, anytime that you need, you can get the infrastructure. And this anytime is also very important. The reason being that many times what happens, particularly for businesses which run intercontinental, and also which will have to offer computing resources round the clock, 24/7. So in those cases, actually what you need is complete continuity without any downtime, or with minimal downtime, almost without any downtime. You need this kind of continuity of service. So if you are looking for other non-cloud kind of models, many times there are, due to issues such as maintenance, etc., etc., there could be downtime, right? So in cloud, typically, because of the way it is modeled, you have already seen some overall architecture of how cloud works. But we'll deal more with it in the subsequent lectures in the class, and it will be apparent that so what cloud offers is kind of not only real-time infrastructure availability, but around the clock and anytime, anywhere, with almost negligible maintenance. So you get all these cloud resources. And clubbed up with the previous point, there is no upfront infrastructure investment. There is no requirement for purchasing, tendering typically in government institutions there is a tendering process for purchase of equipments, etc., and that takes a lot of time, right? So for getting access to this computational infrastructure, you save a lot of time, which otherwise if you had to go through the regular non-cloud kind of models, the traditional models, you would you'd have to spend a lot of time unnecessarily, right? So that you are saving on it over here. Now, the third one is that there is resource utilization, which is done in a much more efficient manner than the non-cloud models, right? The reason being that you are creating in cloud a resource pool, and this resource pool is shared across different consumers, right? So because so basically, what might happen is the single computational unit might be shared across different, not just, it is not just dedicated to one tenant but multi-tenancy, right? So multiple tenants sharing the same platform at the same time, so which leads to improved utilization of the resources. So if let us say that if in some part of the world somebody has been using the computing platform, and let us say that it is night for them, but in the some other part of the world it is morning, right? So you can just intuitively think, using this kind of example, how cloud can give you continued shared 24/7 services for users all across in the world, right? So some part of the world it is night, some other part of the world it is morning, but these computational resources, if it is night, it should not happen that the utilization of these resources reduces because it is night, right? So if these resources are made available to other people through the network, who may be located in different parts, other parts of the world where the businesses are in the daytime, so these resources can be utilized much better, right? So more efficient utilization of these resources. And remember one thing is these resources are geographically spread out, right? So you can get these resources from any part of the world, and to the user, once again, user doesn't know that his or her program or whatever being executed, where it is being executed, that is not known to the user. Now, usage-based costing, so units, it's a metered service, as I said before. So you pay only for what you use, right? You save on the cost. It cuts down on your IT infrastructural costs for the business, right? You save a lot of money. You pay only a meager amount for whatever you have consumed. For others, you do not need to pay, right? So usage-based costing and reduce time to market. So consequently, what happens is, for a product that is being developed for a particular business, because there is a lead time that you are saving on in terms of procurement of infrastructure, which is not going to happen with cloud because of intermittent services, connectivity issues, etc., downtime, etc. So all of these you are saving on that time also, because of the scalability that is there in this kind of cloud model. So you basically, what happens is that you cut down on the cost and you reduce the time to market for the product that is being developed in your business, right? So it leads to reduced time to market. So these are some of these different business advantages of cloud computing. Looking at some of these different models of cloud computing, so at the very bottom, what you need is basically these resources, these computational resources, infrastructure, etc., right, which are going to offer these different types of services. So you need the shared pool of resources. This is basically the heart of everything. So you need the shared pool of resources, and these resources could be anything that you want to share across and offer computational services to the different tenants, right, through this multi-tenancy model. So these resources are offered to the different tenants in the form of different types of services. So when cloud computing concept emerged, at that time, the three basic service models of cloud that were proposed and which became popular since then are three. One is called the SaaS, PaaS, and the third is the IaaS. So software as a service, platform as a service, and infrastructure as a service. So essentially, when you talk about computing, so computing means what? Either you are talking about infrastructure, that means this hardware, computer hardware, or you are talking about software. So these two are quite logically placed, infrastructure and software, because ultimately, when you talk about computer, it is either computer hardware or it is computer software. So these two are logically placed, software as a service and infrastructure as a service. So what you need is you want to offer these computational services in the form of software to the end users, right? So basically, different types of software are made available on a sharing basis to different users across the world. So that is the software as a service. Infrastructure as a service, just the similar kind of thing. For the basic infrastructure, you want to share the CPU, you want to share the RAM, you want to share the storage, right? So software as a service, infrastructure as a service. Now, what is this PaaS over here in between? Platform as a service. So in platform as a service, basically the whole idea is that can we offer computing resources for developers to develop to develop the software or the systems that they want to develop. So these developers are typically these software developers we are talking about. So essentially what you get through PaaS is a development platform, right? So this development platform is made available as service. Okay. Now on top, these two are mandatory, as you can see, but on top, what is running are different service elements and different management services. Service elements in the form of self-serving provisions, service elements have different properties such as self-serving provisions, metering, workload management, and business process management. So all of these different components of service elements have to be basically deployed, right? So there should be provision for self-service, there should be metered service, overall workload should be managed, and the business processes should be managed, because when we talk about cloud, it is more of business attractiveness than of the technological attractiveness. So business is core, business is centric to cloud computing. Now, the other one is the management services, different types of management services in the form of data management, service management, and in between you have integration services, integration of different components, computing components, units, etc. Interfacing one component with another interfaces. Then security and governance, obviously, we understand how important these are. So we have all of these different management services which will have to be provisioned in order to build any kind of cloud infrastructure. So going back, I was talking about the SaaS, PaaS, and IaaS, right? Software as a service, platform as a service, and infrastructure as a service. We will take up one by one, and we will try to understand a little bit further about what these things are offering to the businesses. So software as a service, here basically what you get is some kind of a facility to execute the service provider's applications at the user's end. And these applications are available as services. So software applications, right? So you get, if I told about the Gmail, I told about the different types of Google Google applications, Google apps, etc. So these are all like different types of software which are offered as services by the cloud service providers to the end users. So these applications are available as services, and these services can be accessed via different types of cloud devices. For example, either through a web browser, or it could be through an Android app or any other mobile app. right? And these end users, they do not possess the control of the cloud infrastructure. They cannot control the underlying infrastructure, but they can enjoy these different types of software, these different types of applications that have been built for them to be used. So you have cloud-based email, you have cloud-based different other types of services. For example, sharing some collaborative platform over the internet, like let us say Google Drive, Google Doc, etc. Google Doc particularly. So like that, actually these are different types of software, so which are made available as a service. So there are other different types of software as services as service. There is something called Salesforce and learn.com, and I would urge you after the class to basically search in the internet, visit the website of Salesforce. Please do visit the website of Salesforce and try to understand what sort of software as a service they offer, right? Salesforce is a very commonly used example, and a very primitive type of software as a service example that people use in cloud computing literature. So please do visit Salesforce. So second is the platform as a service. So here the consumers get some kind of a facility to execute different consumer created or acquired applications onto the cloud infrastructure. So there is some kind of a development platform that is deployed for developers to use. The user does not control the cloud infrastructure, as also in the case of SaaS we have seen the same kind of thing. In PaaS also, there is no control the user gets on the cloud infrastructure, but gets the facility, the platform to develop stuff, and the users can control the deployed applications using the given configurations. So many of you have heard about the Google App Engine, right? So the Google App Engine, there is also this Microsoft Azure, Windows Azure, right? Azure, many of you must have heard about. So Microsoft Azure and Google App Engine, these are actually examples of platform as a service. Third is the infrastructure as a service, where it is all about computing infrastructure, CPU, memory, storage, or anything that you can think of other than these, which could be made available to end users without them being able to basically purchase, procure, and deploy them for using them. So all you need is go to some cloud infrastructure as a service platform, and simply subscribe to these services and start using. So you cut down on the cost as well, as well as you cut down on the lead time that it normally takes to buy the infrastructure and start using them, right? So infrastructure as a service provides the facility to access these computing resources like the network, the storage, and the operating system, and these are made available to the end users. So users can deploy, execute, and control any software. In some cases, the user can control the selected network components, such as the host firewalls. So let me tell you that in terms of specifically in terms of the networking, there is another offshoot kind of concept which emerged, which is called the network as a service, right? So which was initially not there, but in the three cloud computing service models, but it emerged as network as a service. So if you later on, if you are interested and curious what this network as a service does, I urge you to please have a look. So you can, using network as a service, you can basically, take control of some of these different networking components, such as host, firewalls, etc., and you can control them, right? So even the switches, etc., so those things can also be controlled. Examples of infrastructure as a service, not specifically network as a service, but infrastructure as a service in general. Amazon EC2, I think this is the most well-known infrastructure as a service, very popular. There is GoGrid, Island, Rackspace cloud servers, Rackspace cloud servers. Like this, actually, the number of infrastructure as a service cloud offerings that are there are enormous. Huge number of infrastructure as a service cloud offerings are there. And in fact, our Meghamala is also another example of private cloud infrastructure as a service. Okay, Meghamala, IIT Kharagpur Meghamala is an example of the infrastructure as a service, right? I do not know whether they have further evolved. They started that way, but whether they have evolved to anything beyond infrastructure as a service or not, that I actually personally do not know, because I have never used Meghamala. But if anybody is interested, basically, you please get in touch with the Computing and Information Center, CIC, the computer center. They basically maintain this Meghamala use, so they should be able to give you further details about what sort of facility are made available for IIT Kharagpur users. So let us do a side-by-side comparison of these service models: infrastructure as a service, platform as a service, and software as a service. So in infrastructure as a service, we are talking about basic computing infrastructure, uh, different resources such as storage, CPU, etc. So in infrastructure as a service, you are talking about these, and these are made available to the end users. In platform as a service, platforms and tools to create, test, and deploy different types of applications and software. And in software as a service, it is typically web-based applications, different applications, but web-based applications which are made available, right? I think this should be pretty much clear by now. What is the difference, fundamental difference between IaaS, PaaS, and SaaS? Um, So in infrastructure as a service, we talk about virtual machines, virtual storage, etc. In platform as a service, because you are talking about development platform, basically it is the units are like integrated development environments, IDEs. And in SaaS, basically the developed software which are made available through the internet for shared usage. Infrastructure as a service, again, it is used by network architects and the developers of the cloud infrastructural platforms. So PaaS, basically it is used by developers, and software as a service, it is used by end users. So IaaS, not simply by network architects, right? So basically, whoever, so it is used by network architects, and also it could be used by anybody who needs this infrastructure, right? So this should be corrected over here. So anybody who needs this infrastructure, they could be using the infrastructure as a service, right? Now, what is the resource life cycle in the cloud, right? So the whole idea is that whenever you need, you use the resources, and whenever you do not, you relinquish, right? So, so how? So basically, the life cycle. So we have to understand what is this resource life cycle, because the resources are made available. They are basically released, and so on. So in between something happens. So we need to understand what is the life cycle of the resources. So the whole idea is that unless you can create this life cycle, so these resources, making them available on demand, and provisioning them as a self-service kind of mode, that is not going to happen, right? So you need to provision these resources in that way. So basically, the end users, they are charged only when they are using the resources, and this is what I already told you several times. It's a measured service, it's a metered service. So you need to be able to measure the units of resources that are being used. So very similar to the concept of renting. Basically, so these concepts that are typically used in cloud computing, like tenancy, multi-tenancy, single tenancy, so we are all actually talking very similar things, like what you do in terms of renting of resources, like renting of, let us say, housing infrastructure, or renting of bicycle or anything, right? So whenever you rent a bicycle, what do? For the number of hours of usage of a bicycle, you pay, right? So whether it is the Ola bicycle or anything like that, so what you do is basically, whatever be the unit of usage, you do not own the bicycle, right? So for a bicycle like Ola bicycle, so what you do is that you start using by making some payment, and then you keep on so using it for certain hours, and then so you pay for the number of hours of usage, and then you park it somewhere, right? So it is very, here also it is very similar. You start using, you register, you start using, pay for the number of hour, not number of hours here, the units of usage are measured in a different way. So you pay for whatever you use, and then you do not pay any further, right, whenever you do not need. So there are certain design considerations for cloud. For example, responding immediately on receiving customer requests, ensuring the availability of the resources at all times in all parts of the world if it is a public cloud, and it is meant for doing so, and returning the assigned resources back to the resource pool after the usage by the customer. So it starts with acquiring the resources are being used, you use them as long as you want, round the clock, and then finally you return these resources back to the resource pool for usage by the other customers. So this is how the life cycle basically is managed, the resource life cycle is managed, and this is how it looks like, right? So with the help of some kind of a cloud service provider, these resources are provisioned. Provisioned means what? What you do is you assign the resources from the resource pool to the end users based on their requests. So you make these, the end users, in other way, the end users, they request for these resources, and these resources are provisioned, packaged, made available to the end users. They start using them. These resources are used for any kind of execution or computational requirements that are there. And whenever they are not used, these resources are released. So between request and release, there is this execution, that means the use of these resources. So whenever it is not used, it is released by the end user, and ultimately releasing means that the resources that were being used by the end user through this particular request, these resources will have to be deprovisioned, and you deprovision these resources and you return those resources to the resource pool of the cloud. So all of these are managed by whom? These are managed by the cloud service provider. The cloud service provider basically, does all of these provisioning and provisioning, execution, management, and release, right? Everything is done together by these end users. By the cloud service provider. The cloud service provider is very similar like an internet service provider, ISP. So in the same way as you have ISP, you have telecom service providers like BSNL, Vodafone, etc. Here you have cloud service provider, right? So Amazon offering Amazon Cloud is a cloud service provider. Google offering Google Cloud is a cloud service provider. Like that, you have so many different cloud service providers that are all across. Like for example, for our government, right? So Indian government, they also have their own cloud, right? So Indian government has its own cloud. The central government, it is, I think, if I remember correctly, the name is Meghdut, right? So Meghdut. So here we have Meghamala for our private IIT KGP cloud, and that one is called Meghdut, if I remember correctly, right? So please double check it. All these information are all available on the internet. So so you need to take care of a couple of different things for the cloud lifecycle management. You need to plan and set up. So in terms of issues such as the capacity, capacity assets that will be made available, setting up of policies, etc. Planning and setup. Then it goes to the self-service, provisioning, like building, testing, and deploying the cloud platform. Then comes the managing and monitoring of it, taking care of issues such as auto scaling, management, monitoring, etc. And finally, billing and payment, that is the metering and the taking care of issues of optimization, because ultimately you also need to optimize these different resources, their usage, and also taking care of how much optimum billing should be done, so that it becomes a win-win kind of situation between the service provider as well as the end users, right? So these kind of issues typically are taken care of whenever you are talking about building a cloud platform, right? So self-service, as I said number of times, that self-service is very important, because whenever you are trying to make available these computational services, so you do not want human intervention of any kind. Everything should happen automatically. All you need to do is to have the users register for these resources, and depending on what the users need, you make these features available through your cloud platform to these different users, right? So important feature of cloud computing is the self-service, and the website through which these customers they interface. What they do is they can select and purchase these cloud services. They can modify some of these service configurations, and so after that, basically the launching of the service, right? So all of these can happen self-served way, automatically, by the platform, right? So ideally it should happen this way. So you start using the purchased resources and services within seconds of the deployment. That is the whole idea and the beauty of cloud computing. So there is no self-service in traditional data centers. The customers need to file an application for the resources, and the concerned personnel will verify and approve the application. These concerned personnel, they have to install and launch the requested configurations. This part actually I need to check why this no elasticity. This part I need to. Right. I understand. So because so that this is basically it is talking about this traditional data centers. Basically, it doesn't have support for any kind of elastic service offering, right? And so in traditional data centers, basically there is handover of the deployed system to the customer, and the customer will have to wait until approval, and which can take days or weeks, right? So this is what typically happens with the customers in a traditional data center. In cloud, you get elasticity. The cloud resources, they change their original as well as the provision configurations. There is automatic increase and decrease in resource allotment. For example, storage services, these storage services could be made available as much as is required, and the customers, they themselves will not be able to know what is going on, but finally they will be billed for increased use of the storage service. The customers may start with a low space, then the space may be increased as and when required, so that this much of elasticity is offered. And similarly, so whenever the limit that was initially registered, it increases, it has been reached. So the automatically this kind of elastic offering of these additional services should be made. And whenever it is not required, the capacity should be shrinked by deleting different files. And so this basically is done on a pay-per-use kind of basis. So units of usage, you pay for those many units, right? So it's the elasticity property of cloud, which is basically making all of these things happen. So elasticity basically benefits both the resources, both the customers as well as the service providers. And elasticity basically also helps you in the sharing of the resources in a way, because ultimately these resources are limited, right? So even if you are talking about in cloud a large amount of resources, but still these resources are limited, right? So unless and until you adopt this kind of resource provisioning and deprovisioning elasticity in turn, ultimately what is going to happen is that so these things are not going to work, right? So so that's why elasticity, so it benefits both the customers as well as the service providers, and so that makes it win-win for both the consumers as well as the providers. So in terms of the workload has to be managed. So because in cloud, unlike in other data centers, you are talking about different types of computational resources which are geographically spread out to be used in the form of the cloud, right? So how do you manage the workload? How do you balance the workload? these are some of these different issues, right? So load balancing is a very important area of research in cloud computing. So how do you balance the load? And these are some of these issues that people who do research on cloud computing, they try to optimize. So management services maintain consistent quality of service irrespective of the cloud deployment and service models. There is little outage, and so if the network is slow, obviously there is a dependency on the network, but if the network is slow, that basically also affects the overall services. And it is very important to ensure overall security between all the different users, because ultimately if the security is not in place, and also for certain applications if the privacy is also not in place, then basically all these cloud models, they are not going to work, because people are not going to use them. So security and privacy are also very important concerns. And the management, data management in hybrid and multi-cloud platforms will have to be done, because ultimately you are talking about different units, multiple units following maybe different policies, etc. So how you are going to manage the data, this is also very important. So with this we come to an end of the introduction to cloud computing module. This is the first module. It was a long introduction, and after that so basically we'll move into more details of each of these different components which we have been introduced to. And so let me just quickly, so any questions so far? Any student? So because we are running out of time, the next thing that I'm going to do is yeah, so let me close this, and we will have a quick recap of whatever we covered yesterday as well as today. And I'm going to, like before, share these slides. Remember, this recap is essentially helping you to get yourselves prepared for these tests that will be coming up in between, right? So and also through this recap, actually you will come to know where you stand in terms of your preparation for these exams. So very simple, because so far we have done only only the introduction. So some of these questions like these I will ask you today, but when we advance more, I think we'll go into more of certain numerical problems or more challenging questions. Those will be asked. So the first question is, what are the categories of participants in cloud computing? This was covered yesterday. What are the categories of participants in cloud computing? Do not look at your so just from your understanding and your memory, try to answer this. Who can tell the categories of participants in cloud computing?
The cloud service provider,
Your
the
name, first
client.
name. The
Sir, I'm
protocol that will
Otanu.
follow is name first. Okay, yeah, go
Uh,
ahead. Who is telling?
Sir, I'm Otanu.
Otunu.
Uh,
Yeah.
the participants in the cloud computing are the cloud service provider, the client, and the cloud service user or the client.
Okay, Otanu. Just let us see if anybody else also wants to speak. Sandeep, Kotapalli, Kotapalli Sandeep, can you make yourself visible, please? Sandeep, what is the issue? Why you don't turn on your video? You are muted actually, Sandeep. You have to unmute yourself.
Yes, sir. I was drinking water right now, sir. I was visible the whole time actually.
Okay, no problem. But try to, because all we are trying to do I know that, if you are turning on your video, sometimes network, etc., those issues also come
Yes.
up. But, so make it as much as possible, make it like a real classroom, right? So
Yes.
that, I also get a better feeling and you also, right?
Yes.
Okay. Yeah.
Yes, sir.
Go
Basically,
ahead.
what the previous candidate said, the categories of participants in cloud computer, the one who manages the infrastructure, that is the cloud service provider, and the person who requests or provisions a machine and uses it, that is the basically customer and the service provider. That's what I think that the categories of participants in
So
cloud computing.
let us have a look. Huh? So let us have a look. So consumers, service providers, and designers, right? Okay. Next question. Quiz. What are the essential characteristics of cloud computing? Essential characteristics of cloud computing. Porimal, you please tell. You have to unmute first. No, we can't hear you. Porimal, you have to keep your mouthpiece closer to your mouth, right? So, yeah.
Can you hear me?
Hello?
Hello, can you hear me?
Yeah, it is better now. Porimal, you please speak a little loudly, huh? Okay, go ahead.
Sir, I can remember one that elasticity is one characteristic.
Mm. Okay. So anybody else? Anybody else? Who else is
Sir,
there?
sir,
Acha. Uh,
sir,
Hers, huh?
sir, this is Arunans.
Arunangs. Yeah, Arunangs. Yeah, Arunangs. Harshit, I will ask you
Sir,
next. Yeah, Arunangs.
sir, prompt service, prompt deployment of resources and its release. Means the same elasticity and uh, unwittious service means
Acha.
without
Okay.
interruption.
Okay. So I think, so now let me give others also a chance. So, okay, I mean, good try. Harshit?
Yes, sir. So am I audible, right?
Yeah, you are.
So the characteristics can be security,
Hmm.
availability,
Hmm.
it can be scalability or whatever other guys are saying, elasticity,
Acha,
and
okay.
user friendly.
Acha. So let us give others also a chance. Okay. So Harshit, let me ask Kanishk. Kanishk, you make yourself visible and please try to. Now your life is more difficult, right? So most of the easier ones have already been said.
Yes, I guess one could be on-demand service.
Hmm.
Um, and, one second, only class. Sorry, sir. And
No problem. No problem. I understand, right? So we are all at home and so many interruptions come. Don't worry. Tell.
yes, sir. So there could be, yeah, as already said, availability of resources, availability, scalability, and uh, what
ठीक
else,
है,
sir?
चलो, not bad. Okay, so let us have a look because class time is already over. चलो, let us look at the answer. On-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Right. This is what I have, but it is true that these are not the only ones. Right. There are a few others also. Okay. This is what I have because this is what I had in my slides. Right. So but obviously there could be even more, like some of you whatever you said. What is resource pooling? Very quickly. Achha, anybody has any class right now? Okay.
Yes,
Yes,
sir.
sir.
Yeah, if you have a
Yes,
class, if any of you have a class, you can just feel free to leave. But for others, let us just finish. It will take 2 more minutes. Um, so let us say, Sai, Sasi Bhushan. Sasi Bhushan? Sasi Bhushan? शशिभूषण disappeared. अच्छा चलो कौन बोलेगा? कुणाल दास. Easiest is to disappear. नहीं, कुणाल तो appear कर गया. चलो. कुणाल बोलो.
Am I audible, sir?
Yeah, you are.
Yeah. So resource pooling is basically so in cloud you can the services that are provisioned can be minimized by pooling the resources together. So it is basically the resources are grouped together and then they are provisioned to users on a kind of shared basis. So maximum kind of optimization can be carried out.
Not bad. So resource pooling is basically, as you said, grouping, right? Grouping of resources for maximizing their advantage and minimizing the risk to the end users. Very good. Next, what is a thin client and what is a thick client? Who will tell? So thin client, Soham. Soham. Soham not answering. Vivek. So let us do Harshit Sura. Harshit, you are muted actually. Harshit, you are muted. Unmute karo.
Yeah. So thin clients are those like regular customers like me or you, and thick clients are like companies. Those require larger amount of resources from the cloud provider.
Okay. नहीं so Kunal Das.
Yes, sir. So thin clients are basically the systems that do API calls and they are majorly dependent on the server hardware. So
Yeah.
every kind of request is processed in the server hardware, and thick client are separate systems on themselves. So they just use the cloud services and then process them inside. Okay.
Very good. Okay, so let us see. A thin client is a network computer without storage and processing peripherals. They need constant communication with the servers, right? And thick clients, basically computers that provide rich functionality and may run independently of remote servers or cloud servers. Okay. What are the components of cloud computing? Very quickly, who can answer? Very quickly, we have to end this class.
Sir, I'm Atanu. The components are infrastructure, platform, like data storage platform, then applications, then services.
Let us have a look what I have. Clients or end users. Clients or end users, services, applications, platform, storage, infrastructure. Okay. Okay. So I think we'll stop over here. So thank you so much for waiting for some more additional time beyond the class. And yeah, so like this actually, you guys please start preparing yourselves for these intermittent tests. I told you actually I was supposed to take a test today. Intentionally I delayed, right? So I thought that you guys will get a little bit of comfort time to make yourselves prepared. Because these intermittent tests will count towards your final grade, right? So this test, one of these mini tests I told you. So the one of the mini tests is going to come up next week. Okay, so please, all of you, please be prepared for the mini tests and please share this information across all the other students. So mini tests will not be scheduled a priori. It can happen at any time, like a quiz, right? Surprise quiz kind of thing. So remain always prepared. But the major tests that we are going to take, those actually we will tell you the specific schedule on when we are going to take those major tests, right? So for that you will get, but for mini tests actually, you should be, and these are going to be very simple questions, right? Like these sort of things. Some kind of idea I'm just giving you, but the questions would be different, right? And obviously these will be different also. Okay.
So
yeah.
So the slides, it would really help if you could make them available.
Yeah. Oh, slides are not available. So I
No.
request the TS to make it available. Okay. And I hope that all of you are over that, what is it called? Moodle, right? So through Moodle, the TAs will make it available.
Sure, sir. Thanks.
Okay, thank you, Kostab. Okay, take care, huh? Have a nice day. Bye.
Thank you, sir.